Okay, good evening and welcome everybody. My name is Bill Diamond. I'm the CEO of the SETI Institute, and welcome to SRI. We are delighted to have SRI as our partners and hosts on this wonderful lecture series. Do we have any first-time attendees at a SETI Talk tonight? Quite a number. Okay. And how many of you are educators? Okay, fair number. Okay, that's wonderful. So the bad news is, since there's so many of you who've not been here before, I have to say a few words before we get underway. But we are live streaming tonight, so in addition to the audience, I'd like to welcome our friends from Facebook Live land who often come and watch these talks. So greetings to everybody watching live for the live stream. And just a little bit about the SETI Institute. The SETI Institute is a research, education, and public outreach organization headquartered in Mountain View, California. We have a rather interesting mission statement compared to a lot of organizations in Silicon Valley. Our mission is to explore, understand, and explain the nature and origins of life in the universe and the evolution of intelligence. So that's kind of a mission statement that I like. It's a little different than what I'm used to, having grown up in the tech community out here. But we have over 80 PhD scientists in the Institute whose research covers or spans the topics of astronomy and astrophysics, climate and geoscience, exoplanet research, astrobiology, planetary exploration, and SETI endeavors, which is our namesake operation, where we actually do search for extraterrestrial intelligence through the use of radio telescopes and optical instrumentations looking for laser signals coming from deep space. We're very excited about the work that our researchers do, but I have to say that I think some of the programs in our education organization are among the most exciting, the most impactful, and the most important things that we do. So I'm really pleased tonight to have with us our Director of Education, Pamela Harman, who's going to be introducing you to some of the amazing education programs at the SETI Institute and talking about how we partner with organizations that can bring the amazing science and educational tools to bear and impact hundreds of thousands or millions of people, either through programs which are organized around Train the Trainer or programs in which we develop and produce curriculum materials that partner organizations then deploy. So these are marvelous programs. I like to think of it a little bit like bait and switch, because I don't think there are two things that they say are guaranteed to be seen by kids as being totally cool. One is dinosaurs, and the other is space. So why not use things that excite and delight young children as tools to teach them science? So if we can give them fun experiences in fields and topics that they think are interesting and fascinating and teach them some science while they're not looking, what a wonderful opportunity. So I think we're in a unique position at the SETI Institute to leverage the cool, if you will, of space science and exploration and SETI endeavors to use these platforms as wonderful means of doing education and bringing science out to the public through amazing programs that you're going to hear about tonight. The SETI Institute, if you'd like to know more about it, you can check out our website, which is www.seti.org. We are a nonprofit research organization headquartered in Mountain View. So if you want to help and get involved and support our work, we're, of course, always looking for new friends, and we welcome any support that you want to give. These programs, we're delighted to be able to bring to the public at no expense, but they are supported by philanthropic donors to the Institute. So lots of ways to get involved with the work we do. But tonight it's all about education. It's about giving kids science without their knowing that it's happening so that it doesn't hurt. And I'm going to turn this over now to Pamela, who will talk to you about tonight's program and introduce our wonderful panelists. Pamela.
Thank you, Bill. Good evening. Thank you all for coming tonight. It is a treat to get to talk about our education programs. They're what get me up in the morning and get me going. So quickly, I'm just going to give an introductory overview of the different programs we have and then let the panel of participants and partners talk. They're going to share their enthusiasm for the programs and for what the experiences have done for them or their constituents. And then should we have a little time for question and answer. So education programs at the Institute were K through higher ed. We reach elementary students, secondary students, and higher ed, undergrad through graduate. Our premier K-12 program is Reaching for the Stars, NASA Science for Girl Scouts, which is NASA-funded. We have an REU, Research Experience for undergrads, that is NSF-funded. Our STAR, we participate in STAR, which is STEM Teacher as Researcher, and that is NSF and privately funded. We have a professional development program for high school science teachers, and science teachers in California have bachelors in science or masters, and some of our teachers have PhDs. And that's the NASA Airborne Astronomy Program. And for PhD students or PhD candidates, we have the Frontier Development Lab teams, which is NASA and privately funded. A little bit more on each of those next. Okay, so quickly, in Girl Scouts, we're developing space science badges, one for each level, and the Daisy, Brownie, and Junior level badges have been released. Yay! I just got my booklets earlier this week, so yesterday. So there's booklets. And to support those badges, we have trainings for council staff, we have trainings for volunteers, we have astronomy camp for girls, and we have astronomy club training at NASA Goddard, which is for girls, an astronomer, and a staff member to go back to the council and start an astronomy club. The other 3 badges for older girls will be out next fall. So not only do we have badges, but we have support programs for girls and staff and volunteers. And there's the badges that girls can now earn if they're Daisy, Brownie, or juniors. Okay, next we have the REU and Compare. The Institute has participated in the REU program since 2006. Here's some statistics. You can see we've had over 163 students plus 10 more this year. We have women, we have people from non-research universities that go on to research careers. This gives them that research experience leg up. Some go into journalism, some go into teaching because they have such a wonderful teaching experience with their mentor that they make that detour. Compare is the California-Arizona Minority Partnership for Astronomy Research and Education, and it is just another pathway into an REU program to reach underserved and underrepresented students. So here, there's a couple of pictures. At the top, you see the REU students get to go up to the Allen Telescope Array every year and spend some time with Jill looking at SETI data. And at the bottom, you can see we are using every inch of space at the SETI Institute. The REU students are crammed in there, and the STAR student is at the back in one little desk, and there's Margaret Race working with her student talking about planetary protection. Okay, the STAR program is actually funded at Cal Poly. We're a participating lab. We don't get any funds, but having the best STEM teachers is one of our goals. That is important. That's, education has always been a core pillar of the Institute. So they get 9 weeks, and it's real research and real engineering. Only by living it can you share it with your students. That's the motto of the STAR program. We've had 13 STAR interns at the SETI Institute in 10 years. And here's a couple pictures. They have a poster program. Imagine trying to pull a research project together in 7 or 8 weeks and delivering a poster talk at Ames or the STAR conference. Zoe Sharp, who you'll meet shortly, went to New Zealand with a Sofia deployment and worked in a lab. And this is a temporary lab that had to be set up in a hangar at the airport at Christchurch. Okay, next we have the NASA Airborne Astronomy Ambassador Program that was originally part of the NASA Sofia mission, and it is now funded directly by NASA Science Mission Directorate. We have selected over 130 educators to go through a professional development program, and then they get to fly on Sofia science flights, nominally 2 flights, up all night, see STEM in action. We call it Sofia, or astronomy, the gateway drug, because there's so much to astronomy. There's engineers, there's math, there's graphic artists, there's mechanics, there's all kinds of support staff. So there is a wealth of careers in STEM, even if you don't think that you're an engineer or a mathematician. Marita, who you'll meet in a minute, was one of our first pilot test, not pilot, but she was in the pilot program where we were first figuring out how to do the ambassador program, and has come back in the later cycle to be part of the program with the professional development and curriculum. So the cycle 6, teachers have had their professional development. It started in January, and they're getting ready to fly this fall. Cycle 7, we have the memorandums of understanding with our districts, because we have to partner with districts, and the teacher application for that will happen this fall, and then they'll start their professional development in January. Okay, so up top, there's Marita with Teresa, who's Paulson from Wisconsin, and Coral Clark, who's still in the Center for Education, wearing their semi-world famous blue Airborne Astronomy Ambassador jackets in front of the observatory. Most importantly is the work that the teachers do in the classroom after the flight. And so you'll see the picture there with teachers in the classroom, and we now have a curriculum for the teachers to teach. Okay, FDL, I need, what's not on the slide is FDL stands for Frontier Development Lab, and it's deep learning, it's machine learning, it's artificial intelligence, and so we have teams at the Institute who are assembled to tackle a particular challenge, such as asteroids, solar weather, mapping the lunar surface, making the search for exoplanets more efficient. And what's really unique in this program, as with the RE View, it's an intersection between our Science Center and our Education Center. Because obviously the REU students are working with science mentors. And in FDL, we have always included PhD candidates as well as postdocs and experts in the field. So over the last 3 years, you can see we've had 22 PhD candidates working with these teams on these advanced engineering artificial intelligence teams. And again, here's a couple pictures, again, how we're using every square inch at the SETI Institute. This year, we didn't even have room for all of the teams. Some of the teams were at 2 other locations. And so you can kind of see at the top how they're divided up into tables. And we have another corner where we stuck another team. And they work together on those tables. And then almost every other day, there's a presentation where they all listen to the status update from one of the teams. And so there's a presentation going on there. So as you can see, we have a lot going on, again, K through 12 through higher ed. And I want to introduce our panelists next. Okay, so first is Jessica Henricks. She's from Girl Scouts of Northern California. She is the STEM program manager, space science and making, and she has, and come on up, and she has her master's in education from Harvard and came back to California to work with Girl Scouts. Next, I'd like to bring up Brianne Baisea. She's an RU student. She will be transferring from Los Venados Community College to San Jose State. She's in civil and environmental engineering. She worked with Pascal Lee on mapping routes for exploring Mars, and she's an engineer. I am too, so she's one of my tribe. Tatiana Gibson is also an RE student, Cal Poly San Luis Obispo, in earth science and astronomy, working with Lori Fenton, also on Mars, and Aeolian features. And she came to us through the Campare pathway, and she'll address that a little bit. Next, yeah. Okay, next, Zoe Sharp. She's a STAR alum, and the STAR program is set up that you're eligible 3 times, so she got to participate twice. As I mentioned earlier, she worked with the Sofia Instrument Lab down in Palmdale, took a trip to New Zealand. And then her second stint was working with Margaret Race in planetary protection at the SETI Institute office, and she teaches here locally in Mountain View, or Mountain View that way. Marita Beard. Marita is a physics teacher at Lee High School in San Jose. She worked at the SETI Institute in curriculum development before she went into the classroom. And before she was in curriculum development, she was at NASA Ames and worked on Sofia. So, and now she's a NASA Airborne Astronomy Ambassador. And last is Alec Shinze. He is a PhD candidate from the University of Oxford. He is studying computational geophysics and worked on a solar weather team, and they made their technical presentation today. Okay, so my first question is, we'll start with Jessica, and I was just curious how working with the SETI Institute on the Girl Scout Stars program has been good for the council, been for Girl Scouts that you know.
Well, it's really been tremendous. It's actually the reason why I have the opportunity to work with Girl Scouts, which is amazing. The SETI Institute and Girl Scouts of Northern California is actually a council. So Girl Scouts is an interesting structure. There's a national organization that issues the badges, and then I'm with Girl Scouts of Northern California, so we've got about 70,000 adult and girl members. Because of my boss, Jean Fay, the director of STEM program, had a long history of working with SETI Institute back to the mid-aughts, doing astrobiology workshops. There was a resident track at NASA Ames for that. And then I came on right at the tail end of the development of Girls Go to Mars, which is an incredible program for middle school age girls. It's got a variety of activities to learn about Mars and sort of Goldilocks planets, all those good things. And so actually that was sort of one of the things that led to now Girl Scout Stars, which is, NASA, as Pamela said, NASA Science Mission Directorate funded program. It's got so many different things going on, from the badges for the girls, and I also really consider it for the adult volunteers as much as for the girls, because they're getting a lot out of it, as well as adult learning camps, girl camps, astronomy camp trainings. And so when we received that funding, that actually employed me. On my first day there was the Girls Go to Mars training. And watching all of these council staff come from all over the United States to learn about the Girls Go to Mars curriculum, a free online curriculum available, SETI.org, GGTM. I definitely do a lot of promoting of it until the badges came out 2 weeks ago. That was tremendous, and just the exposure to the subject matter experts and the resources is really the greatest value that SETI Institute brings to the Girl Scouts, both the national organization and our council ourselves. The subject matter experts are not only within the SETI Institute through the original PI, Edna DeVore, now our fabulous PI, Pamela Harman, and but the subject matter experts go beyond the SETI Institute. Through SETI Institute, we were connected with tremendous expertise through the Astronomical Society of the Pacific, Ares Scientific AdNet out of Goddard Space Science Center, University of Arizona. So that has connected the Girl Scouts community with all of these amazing experts who bring forward all these resources online. I'm thinking, I'd mentioned it's as much about the adults as the girls. We all think of Girl Scouts as being girl serving, which we absolutely are, but Girl Scouts is not a direct delivery program. Most council staff don't do the teaching themselves. We actually go out there and make sure we create the resources for adults to be able to support the girls. And in the process, a lot of adults discover that they have more abilities in space science than they might have expected, a lot of intimidating things about space science, and one of the first things I got to do with the learning was go to University of Arizona for the adult learning camp. Yeah. And there I was with 12 other adults who said, we are passionate about bringing STEM to our girls. We're not sure how to do it. Teach us more about space science. And while we were there with our partners, Don and Larry of University of Arizona, they handed out moon balls. A white ball on a stick. There is nothing more simple than a moon ball. And you wouldn't believe how transformative it was for these adults who were then going to go and share this with the girls. We walked outside, sunny day, moon was out in the sky, hold up the ball, noticed the shadow on it, and just you could hear gasps. It was crazy, just that they had never really thought, these are adults who are passionate about STEM, had never thought about it. So through these new badges, we're equipping the adults to connect with the girls, to bring that same sense of wonder to the girls.
Thank you. Yeah. So, Brienne, how has participating in the RU program at the Institute helped you learn? Has it had any effect on your career path?
Of course.
Okay.
So I actually got reintroduced to how amazing space was last year. NASA does this program for community college students called NASA Community College Aerospace Scholars. And I came here last summer to Ames Research Center and was blown away. This was definitely a turning point in my academics and what I wanted to do as a career. And I knew I had to get back into doing space stuff. So I was on Google and I searched up RU internships. And SETI was not the first one. I had to dig through hundreds of different hyperlinks to find SETI, but I did, and there was a list of projects. And I remember thinking, which project do I think I could best fit? What skills do I have that could accomplish the goal of this project? And I found one with Dr. Pascal Lee, and I'm now traverse planning and creating traverses of Noctis Landing, which is a proposed human landing site and human exploration zone for the first missions to Mars. And the first day I met him, he told me, looked me dead in the eye, because he knew I was a civil and environmental engineering major, and he said, I am going to turn you into a planetary scientist. And every day that I've seen him, he always asks me, are you bored of it? Are you done? Is this the path that you want to take? And every day I look at him and I'm like, I don't know. I love it. I love learning every day, just so many things and discovering so many things. Using the programs that I help code and beta test, but we'll see in the future. Maybe I'll become a planetary scientist.
Okay, Tatiana, same question. Why did you pick the SETI Institute RU program? What has Compare done for you? And has the experience changed your how you feel about STEM or space science?
So 5 years ago, I was sitting in my bedroom as a sophomore in high school, and I was like, you know what? I found out about this word astrobiology. I didn't realize you could have a career in it, but apparently you could. I learned about the SETI Institute. And I remember I was like, well, how do I become an astrobiologist as soon as possible? So I Googled astrobiology internships, and lo and behold, the SETI RU shows up, and I see that you have to be at least a college sophomore to do it. So, for 4 years, I was like, you know what? I got to go and check out that RU as soon as I possibly can. And I remember running downstairs telling my mom, I'm going to be an astrobiologist someday. And that word has a lot of connotations to it, and I had to kind of explain to everyone what I meant by what I wanted to do as an astrobiologist, which became now my goal of being a planetary scientist. But now, I got to the age where I just finished my sophomore year in college, and I was like, this is my year, I got to go apply for that RU. And I actually stumbled upon a fantastic opportunity to take an alternate path into possibly getting that RU, which was when this program Compare showed up at my university. And to remind you what Compare stands for, that's California Arizona Minority Participation in Astronomy Research and Education. And I realized that I fit into a lot of these categories. I was going to a California state college, so an institution that doesn't necessarily serve that many graduate students. I also happen to be a minority student, and I also want to have a career in astronomy and planetary science. And when I saw that SETI was one of the approximately, I think, 10 centers that's served by Compare, where you can take this alternate pathway into a traditional RU, I saw that that was just my chance to kind of take this this other path into what I always wanted to do. And I was actually called upon to be kind of like this liaison between the professors that were involved in Compare and my astronomy club that I'm the president for at school. So I was the spokesperson for it, and I was also applying for it, so I was very much involved in the whole Compare process. When I found out that the SETI Institute had chosen me as one of their students, I was just so excited. I was in the middle of physics lab, and I started screaming. I was like, oh my goodness, this is it. Like, this is my biggest dream come true. And it was indeed. This summer was just absolutely the most incredible experience. Getting to work on Mars was just the best time ever. We still have a week and a half left, and Brienne and I are kind of wrapping up our last week here at SETI. But it's just been an incredible opportunity to both network with other students that are interested in planetary science, as a lot of us are, and maybe Brienne is becoming one of them eventually. and getting to work with also the mentors. I have two mentors, Dr. Lori Fenton and Dr. Janice Bishop, who are both just experts on geology on Mars. And it's been just the best time getting to learn how interdisciplinary astrobiology and planetary science are, and how many different paths that you can take into it. You see people that have backgrounds in geology and astronomy, biology, just anything you can imagine. And all of these are, I guess, at the end of the day, what the SETI Institute is all about. And I love being in that collaborative environment of getting to see just how many ways there you can get into the field that I got so excited learning about 4 years ago now.
Thank you. Okay, so Zoe, what did the STEM program do for your career? Were there any changes in your career path due to the STEM experience? And why did you come to the Institute to work with Margaret on planetary protection?
So I always knew I wanted to be an elementary teacher, and I was interested in science. Probably a lot of the students that I have are similar to me, where it was exciting to see space and they were really thrilling things, but I had never considered that I would get into a field that had anything to do with science. And when I was in undergrad, I had a lot of mentors who helped push me towards the STAR program, which is science teacher and researcher. And I was pretty nervous to be an elementary educator applying for a program that takes mainly high school science teachers or people seeking out that career. But I was really fortunate. My first placement was with Sofia, which works with teachers, and then my second one was with the SETI Institute with Margaret Race. And she was really gung-ho about taking on somebody who was an elementary teacher, and really patient with me while I was learning about all the different ways to do research. And I think it showed me how different the careers are between teaching and STEM, but how many things I can use to integrate into my classroom. And so now I have my poster booklet, and it sits in my classroom, and it has all the different interns' posters in it. And my fourth graders will pull it out randomly during reading, and they'll sit there and look at these posters and have no idea what any of the research topics are or anything that they're reading. But I can see that even that small thing is showing them that they're able to go towards a career that they didn't think they could necessarily do. I'm now working with Margaret Race and her STAR internship, Lauren, to create a project about the mission to Mars for my fifth graders. And so I'm really excited to actually get to use the research that I did last summer to now integrate with my students. And so they're going to get the chance to use research as well in the classroom, learn about Mars and learn about Earth, and come up with their personal opinion about if we should be going to Mars or not. And they get to sort of experience what I experienced. And I think it's just motivating and engaging for kids that age to see someone like me who wasn't going down that path get really excited and be a part of it.
Hi, Marita. What do you want to talk about?
So I have actually worked for the SETI Institute. It was my first job out of college, and it's really cool to see the resumes that there's so many Cal Poly female grads. I started out working in astrophysics research on a team that was designing an instrument for Sofia, and then I moved into education and public outreach, and they were very supportive of me pursuing, because I'm living my dream. I've always wanted to be a teacher. I actually told my students that today when I tell them about Sofia. Every year I start off the year and tell them about my participation in Sofia, and then they go, why are you here? What, you had a chance, you're working with in astronomy. I said, because I'm already living my dream. I want to be a teacher. I want to inspire young women to pursue careers in science. And so I'm where I'm supposed to be. But I feel like it's full circle, that job that I had right out of college. I can share that experience and then participate as a teacher in the Sofia program. There are many ways, because Pamela says, share about how your participation in Sofia has impacted your classroom. I started, my first participation in Sofia as a Cycle 0 teacher was back in 2011. I was teaching at a different high school in our district, and the excitement of the students hearing about my participation, and back then it was a big deal. Like the news media was all over, and the kids are like, why are there news people coming talking to you? And so it was a great experience for me to share with them my experience on the airplane. And that first experience, I did a lot of sharing with them. You do not have to be a PhD scientist to be a part of the Sofia program. I taught at a school where I was only teaching 1 or 2 sections of physics, mostly earth science. So there wasn't a lot of students choosing to take the higher physics classes. Now that I'm in a different school and district, I teach nothing but physics, and I talk about Sofia. My second participation in Sofia last year as a Cycle 5 teacher, I have not flown yet because due to technical difficulties of the plane, but it kept the kids all year. Well, tell us a little bit more about Sofia, and they designed a curriculum that we can implement in our classroom that's aligned with the new science standards and GSS standards, and the kids were really excited about it. They loved the camera probe, and I was sharing it with the other teachers of my district at the professional development day that you have to do this activity because it's aligned with NGSS inquiry practices, and the kids really loved it. And it's so simple as playing around with LEDs through filters, but the kids were really excited. So I'm going to give you 2 examples of how it impacted individual students. This summer, a student of mine that graduated from Branham, which is another high school in San Jose, she graduated in 2012. She sent me an email saying, hi, I don't know if you remember me, but I was in your astronomy club, and I also took physics from you. And she said that she is a astronomy student at San Jose State. She's active in the San Jose Amateur Astronomers Club, and she said, having your class and hearing about your experience in Sofia is what pushed me into astronomy. This year, I have a student who took regular physics from me and is taking the 2nd year AP physics class. And she asked me, walking in the classroom yesterday, she said, are we going to get to do more astronomy like the stuff we did for Sofia? Because I thought it was really fun and I want to learn more, and that's what I want to major in. And she's a senior now. So there's so many ways that I haven't heard yet of my students, but I've been able to share my experiences about Sofia with my colleagues and with my students, and they're still excited. And we're keeping our fingers crossed that I fly in September.
Okay, Alex, PhD candidate, university at Oxford. Why would you walk away from your PhD program for a summer and come to the SETI Institute? And what did you do with the solar weather team?
So I came because I really needed to get away from my PhD. No, seriously. Actually, that's part of the reason as well. But I came because I don't know if, FDL, just a word about the program first. So it stands for Frontier Development Lab, and it's a research and development accelerator that brings together artificial intelligence and space exploration. And it's just, so I do a bunch of AI in my research, and it's a very cool field with a gigantic future, and it's a lot of hype around it at the moment. But also, I'm a big science fiction fan. And when I saw the kind of advertisement of FDL, in my mind it went straight. I don't know if people like science fiction here, probably yes, but it went straight to like, AI, space exploration, Asimov, robots, like Interplanetary Federation with robots everywhere. I was like, oh yeah, I want to do that. And basically, I think so. Of course, we're not there yet in the projects that are in FDL, but I really believe that this sort of program paves the way towards the sort of next big, in my opinion at least, revolution we'll have. We had like whatever industrialization, and then maybe transistors, internet, whatever. And I really think that space exploration and robotics will be one of those as well. And so I was really excited to sort of take part in something that paves the way towards that kind of really cool goal, in my head at least. And the sort of things we do, so I don't know, I'll just say a few projects that we have. There are people looking at using AI for exoplanet detection to improve state-of-the-art stuff. There are people looking at how to coordinate if you have multi-agent robotic systems doing space exploration, how to coordinate those. It's a very, very hard task. Our project in space weather was about basically the sun sends a bunch of energy our way, and it impacts the atmosphere, the upper atmosphere, and it has a big impact on satellites or on the power grid. We had a radio blackout, for instance, during the hurricane, which prevented rescue operations from doing anything. So our objective basically was to use AI to predict or model what the sun will send our way, what kind of energy it will send our way, and how it will impact our atmosphere, so that we can basically take that into account in a bunch of models for satellites, etc. So yeah, that's the kind of projects that are going on in FDL, and it's been an amazing summer. It's very, very intense. It's 8 weeks. You're working nonstop with your team, with your mentors, with the other teams as well. So it's very challenging, but you learn so much by interacting with people. There's like so much knowledge from the mentors, from your teammates. So yeah, overall, yeah, it's just an incredible experience, and I highly recommend any PhD student or anyone really to do that if they can.
Okay.
Yeah.
Okay, well, I'll do some quick follow-up questions on the way back. So, Alex, to you, quick follow-up. Do you think it's important for the Institute to keep the PhD candidates as part of the teams? And why?
Well, we're cheap labor, so I think.
Well, we're all about that. Okay.
No, seriously though, I think it's very important because it's sort of I see it as a win-win situation. I think a PhD student is already like sort of at least halfway or towards the end of the PhD, we're already sort of formed scientifically. We hit the ground running, so there's not like a big learning curve. So 8 weeks is a good time to actually get a project done, and the student also learns a lot and benefits a lot from the network that we create. It's a very tight community, at least in my experience. We became really good friends with everyone, and yeah, for me it's a win-win situation. So I think it'd be great if it keeps going, for sure.
Thank you. Marita, do you think your Sofia experience and the ambassador professional development and the curriculum, do you think that translates into better grades? Or, I mean, because you talked about interest, is there any way that you can infer that has an impact on grades?
You mean better student learning outcomes?
Better student learning outcomes, standard-based learning in the classroom.
Yes, because the Sofia curriculum that I used, it's real science articles that they're reading, and so the kids are engaged. It's not something that I just made up and wrote just as because a lot of times teachers use stuff like, we can't find the thing that's age appropriate, and so we sort of like take what we know and sort of change it, but this is real science, real articles, real experiments that they can do, that they know that scientists have had experience working with, and so that will translate into, like, they're going to be better engaged, and they've already asked better questions than they've had before.
Oh, awesome. Thank you. Zoe, I'm curious, what's a planetary protection concept or regulation or process that you've been able to translate and use in your elementary school classroom?
One of the biggest things that I used first was actually just the research skills, because I spent hours going through different research articles and just learning how to do so much literature-based research that I'm able to use that constantly in my classroom to explain that this is actually what researchers do, and you need to reread things and learn things personally to be able to understand it yourself and conceptualize it. One of the most interesting case studies, though, that we talked about last summer was a man who had a flower that was in the International Space Station, and he tried to bring it down into Florida and actually got a ton of different federal regulations put on him, and he had to go down a different way. And I talked about it with my class when we were learning about government, because we were just learning about the different things that you have to go around to be able to understand the world that we live in. And we do a lot of critical thinking debates. I was 4th grade last year, and I'm going to 5th grade with these kids. So we do a lot of debates about their beliefs and what they think about it. And so it actually brought a lot of thoughts about what they think government should do and trying to look after the safety of each other. So I think the case studies have helped a lot to engage the students and give them a very random thought that they would have never considered and help them think more critically. But then it's also given them an understanding that the skills I'm giving them are not completely unusable. They're actually going to go do this when they're an adult and when they become older, and these are careers and skills that are going to be lifelong, and they can always use them.
Thank you. Tatiana, what's something surprising that you learned? Something, or let me rephrase it, or what is something that you were surprised that you learned this summer?
So this summer, I've been doing a lot of looking at remote sensing images of Mars. So there's 2 cameras that are on board in orbiter around Mars right now. One looks at the composition of minerals on Mars, and the other just takes really high-resolution images of Mars. And it's been really fascinating to see just how fine some of the details you can make out on the surface of another planet are. So I showed up on my first day, and my mentor, Lori, explained to me what my project entailed. And I can't believe that I get to spend all day looking at these beautiful pictures of Mars and resolving such fine detail. You can look at features on this planet that's so many millions of miles away that are down to just a meter wide. So I feel like I have this whole new set of eyes that are just seeing places that some people haven't even looked at before. Just some of the images that I look at, I feel like I'm the first person to have just looked at these very tiny features on Mars ever, and it's just super surprising to see how much there is to see on these images of dunes that I'm looking at. You would think that there isn't that much to dunes, but there's just all these really beautiful surface features that I literally get to look at all day, and that's been a very fun time.
Brianne, same question. Is there something that was surprising about your learning this summer?
So like I said earlier, I'm a civil and environmental engineering major, and one of the first weeks when we started the RU program, we went up to Lassen National Park, and that's where we learned about a lot of geology. For me, I have no idea what I'm looking at when I go hiking. I don't know the difference between a cinder cone and another volcano. So going to Lassen National Park and the Hat Creek, it was amazing. I see things in a totally different way, and because I also study Mars, I'm supposed to know what I'm looking at when I look at these pictures. So it was very I see things in a totally different way, and I appreciate that. And I appreciate things more here on Earth as well as on Mars. So it's funny how we can look at a picture and I could be like, oh, I know what that is. And no one else knows what it is. And actually right now, Pascal told me I am the only person in this universe that knows more about Noctis landing than anyone else. So that is something I will definitely put on my resume. But just the vast knowledge that we've been learning in the past 10 weeks has been incredible. Every day is exciting, never boring.
So I'm going to pass it back to Alex, give him a chance to answer that same question. Is there anything surprising that you picked up along the way of your FDL experience this summer?
Actually, I think it was surprising how little we know. We arrive and you think, oh, I'm gonna do like this and that. You know, you have a good idea for the project or whatever, and it turns out that there's vast amount. You know, there's so much stuff you hadn't taken into account, and yeah, there's so much stuff happening that you hadn't thought of, and yeah, just for me, it's like a constant thing in research actually that I find very interesting. But yeah, otherwise, what I really enjoyed was looking at again very cool images because we were working on the sun, and you get these. I can just speak louder.
Yeah.
Thanks. Is that one working?
Yeah.
Okay. Yeah. Oh yeah, it is working. Okay. Yeah. The other part for me was actually I was completely new to solar physics. Well, pretty much new, and it was just so cool to look at those. So there's this satellite called Solar Dynamics Observatory that takes these high-resolution pictures of the sun. I'm sure you all know it, but it's like 4K images of the sun. And also these like really cool colors. They're artificial colors because it looks at wavelengths of non-visible light. So they got just to choose whatever colors they want for the picture, and they chose like really cool ones. And you can see so much activity in the sun. You can see the active regions, but you can see the flares. You can see stuff moving around. You can see like the magnetic field with all the particles inside it doing crazy stuff and then exploding. And I don't know. It's just, and we always had it. Well, the screen was taken by a presentation in the picture in our room, but for our team, we always had like the big screen with the massive pictures of the sun in real time, actually. And that was, if you're bored of what you're doing, you just look up and look at that picture and you're like, wow, that's so cool, and get back to it. Yeah.
Particular experience with a Girl Scout that exemplifies what we're trying to do. They are space science badges. It is about astronomy, but it's about STEM outcomes. So is there a particular anecdote about a Girl Scout that you could share?
It's funny because there's so many small snippets, and none of them will possibly capture all of the potential impact of it. But it was actually the opening remarks that was making me think about the sneakiness of it, that sometimes it's not necessarily this is science. This is an informal education opportunity where the girls are learning collaboratively. They're learning from each other as well as from the badge materials. But sometimes there's events, and I'm thinking actually of Golden Gate Bridging this last year, where we brought all sorts of things to explore sunlight, and it was just so much fun. We had UV beads there, and these are girls who were bridging from 5th grade into their middle school years, and as they were discovering the UV beads and going around and trying to hide them from the UV light, what will block the UV light, there was just such a generative thing that with these adults who were there supporting them, they were doing hands-on inquiry-based science where they didn't have to fully understand the electromagnetic spectrum. They just needed to start to discover there's invisible light that's out there, and there is something that detects it. And I think actually one of my favorites is looking over at you. You were having them catch rainbows. So one of the things when Girl Scouts bridge between levels, it's all about rainbows. And there's nothing like rainbows to learn about information in space. And some of the most amazing people in the badges feature some of the women, like the Harvard computers, who throughout history have discovered how light tells us about space. So as the girls were there, just as simple as a box lined with white paper and a prism, and some adult volunteers and Pamela there are saying, catch this rainbow. And they're like, wait, what's making the rainbow? Where is, and they're trying to understand what the rainbow was. And that's really what it is it's all these little sort of moments that excite me the most are when girls may not have had the opportunity, incredible teachers like you, to get them excited about the way that you can learn about the world. And these informal learning opportunities really can plant a seed that can germinate and grow into fabulous STEM careers like the folks on the panel here.
Yeah, thank you. So we've got some time left to open up for questions from the audience. There's a microphone up front if you want to ask a question. And while somebody's making their way to the microphone, I'll open it up and see if there's anything anybody else wants to add on the panel, if there's something that you just thought of that you have to share. Well, I know Alex and Tatiana and Brianne have been working very hard. Marita has started teaching. Zoe is in session. She starts next Monday. Okay, so we have a question.
Yeah, it's really encouraging to hear a lot of the stories and anecdotes about the increasing role of women in STEM. I think it's also important, though, to remember that there really is a problem we're trying to solve here. And as encouraging as some of the progress is, I'm curious if any of you feel like you have any insights into what the underlying cause is of the underrepresentation of women. And in particular, the part of it that I'm really puzzled by, and I'd be interested in anything you have to say about it, is what happens between middle school and high school? You know, my current passion is I'm mentoring student robotics at both the middle school and the high school level. And what I find is in middle school, usually more than half of the students are female, and they typically do a noticeably better job than the boys. And by the time you get to high school, it's usually about 5-to-1 boys to girls. And I don't know why that happens. I wonder if any of you could shed any light on that.
I can speak a little bit to that. I don't claim to understand exactly what happens in middle school as well. My daughter just started as a freshman, and from my own personal experience with her is confidence in math. And if they don't have a confidence in math, there's this, math and science are correlated. And so if you don't continue to foster that confidence in math and say that, no, you're good at math and that, you can do this, we need to continue to foster that. I keep trying to encourage girls to take my senior level physics class. Over the last 2 years, last year I had 2 out of my 27 students were young women. And so I encouraged my junior students to take the second year physics class. And so I specifically approached certain girls that show to me that they're interested in science and that they're going to be successful, have ability to be successful. And so last year I had 2 out of 27. The class is a little smaller, but I now have 5 out of 20 are now young women in my physics class, my AP2 physics class. But I think there is something that happens that in girls in terms of like if they have a good science teacher, we do make an impact. My daughter's like, I don't really want to take physics, and I'm like, but you have to, because you live in my house. But she's not the only one like that, right? So she had a bad experience. She loved science. She had a great science teacher, 6th and 7th grade, and then the science teacher changed, and it wasn't a science teacher that made it exciting and engaging, apparently. So she's not as engaged. But there are other things where, like, for some reason, something happens where girls, they don't think they can handle it. They think, well, that's for the boys. And our engineering classes at my school are still male dominated. And there's another woman who teaches the engineering classes trying to encourage that. So I started what's called Wisdom, is a club at my school, and it's We Are Inspired by STEM. And anybody can be in our club, but we feature women in STEM careers. And they come at lunch and give lunchtime talks, and they talk to the girls about their education and career pathways to where they're at. And so we do the full spectrum, doctors, engineers, computer scientists, and we're a relatively new club, and we're kind of small, so even just the membership of my club tells me that, there's still not enough girls on campus engaged in that. But I think just building their confidence, I think, is the first thing. And having someone reach out to a girl, like the Girl Scout program, and saying, you can do this. This is possible.
If I can add on to that, there's a lot of research on the subject, and there's social and cultural factors. Culturally, some cultures are not as supportive. In some cultures, women are seen to have certain roles. Socially, there's a lot going on as middle school and high school when we start getting interested in who we might date, or who might want to date us, or who liked us last week and who doesn't like us this week, and all of that plays in. And so I want to on behalf of Girl Scouts and all girls schools, there is research that shows that the STEM outcomes for young women are much better if they're in all-girl classes, or even if they're in all-girl small groups within a co-ed classroom. Girls, I'm going to be shouting Girl Scout processes here, but girls learn by doing, girls learn collaboratively, and girls want to change the world. So if they want to make the world better. So if there's context for studying physics, how can we solve problems with physics? If there's context for studying chemistry, what world problems can we solve by understanding chemistry? That makes a difference to all students and not just girls. But it's context, and Marita mentioned confidence, and there's some research on this as well, and that there's a difference between how men view themselves successfully in the classroom than how women view themselves successful in the classroom. Women can work very hard at physics and have an A, but not an A+, and think that they're not very good at it and that they should not pursue science. Men can go, yeah, I got a C+, I'm going to MIT, I'm going to get into MIT one way or the other. There is that cultural difference, and so part of the work of making, instilling confidence in women is helping them understand that they are good enough. That an A is good enough. It doesn't always have to be the A+. So there's a lot around it. That was a really, really powerful question. So yeah, I hope that helped. And we'll try to take one more question, and if there are no more questions, I'll turn it over to the panel and see if there's anything else anybody wants to add, and then I'll turn it over to Bill. We have one question, yes, come on down. Do you have a question?
Hi, it was great having you guys on the panel. I have a question for you, Alex, more on the FDL. So what kind of work are you guys doing in the AI space? Do you guys publish very actively? Do you guys publish your code snippets? And do you guys try to get more like machine learning and statistical community involvement in some of the work you're doing there?
Yeah, for sure. I think, so last year I think there was a couple papers that were published, and they presented a couple posters at NIPS. And so this year we have already submitted abstracts as well for a few conferences, including NIPS actually. So definitely the point is to get that out into the community, the research community. I mean, it is mostly academic research, so that's absolutely the point. And in terms of code, it's all on GitLab, and it's going to be made available as well. You know, after we've sort of written up the papers and published, etc. So in due time. And there's also a push for some of the projects, including ours, that because basically we went through all the process of getting the data ready for AI. Basically, now there's a good, clean data set, and that's going to be made available as well. I don't know. It's not going to be Kaggle. It's just going to be. I mean, we're going to publish it. It's going to be linked with the paper probably. So we haven't decided on an exact form yet. But yeah, absolutely. I mean, the point is to get as much as possible out there in the research community for sure. So come to FDL 2019.
Yeah. FDL talks on Thursday are going to be web streamed.
Yeah, so a couple more words, if this one's working. Yeah. On FDL is, so there's a website for the program. It's frontierdevelopmentlab.org, so I'd encourage you to visit it. The output of the first 2 years, so the team output, was captured in a proceedings document. It's basically FDL Proceedings 2016-2017. So you can download that entire document off of the website. It's open to the public. Most of the work in terms of any software that's been developed, a lot of the teams are putting their code up into publicly accessible web links so that people can, well, they want developers and scientists to be able to download and utilize the software tools that they've developed, work with them, improve them, apply them to different data sets, et cetera. So yeah, there's a lot of opportunity to learn more about the output of the teams, what they've done, and also get access to some of the tools they've developed. So check out frontierdevelopmentlab.org. Also, Intel is hosting a more public conference. So the teams, I think Alex is a little bit tired, which I can understand because he's been working, like 20 hours a day for the past week or so, getting ready for the presentations that were made today to mostly our NASA stakeholders and others. So giving really an in-depth presentation of the results to NASA today. On Thursday, Intel is hosting an event at their corporate headquarters in Santa Clara for FDL, in which the teams will be presenting a more, I would say, accessible version of their results to the general public. I think you have to register for that. Is that correct? But it is free. It's open to the public. So if you're interested, you can check with the Institute and get more information about it. That is Thursday afternoon from 2 to 5 p.m. There is a reception that will follow. Intel has been one of the big hosts. So the other thing about FDL that's probably worth mentioning is that We talked about it as public-private partnership, so NASA is one of the key funders of the program, and we're predominantly focused on NASA priorities in terms of science and research questions and challenges. But it's also an example of public-private partnership. So in addition to NASA resources, we have funding, we have tools, both hardware and software, cloud resources, and subject matter experts coming from industry. So IBM, Intel, Google Cloud, Lockheed Martin, who am I forgetting? NVIDIA, KX Solutions, Space Resources, Luxembourg, X Prize. All of these organizations have contributed combinations of funding, of subject matter experts, hardware, software, machine learning tools, cloud resources, et cetera. So it's been a great example of collaborative science at a very high level, although for a very focused 8-week period. So definitely check out more about it on the Frontier Development Lab website and the SETI Institute's own website.
And also the Thursday talks, there are 10-minute talks from each of the 7 teams, will be live streamed on frontierdevelopmentlab.org.
Oh, that's right. That's a good point. So you can watch them as live streamed. Yep.
And if you go to SETI.org and select Education and Outreach, you can find more detailed information about all of our education programs, and also how to reach me if you have questions that we haven't answered today.
Is there a question here? Go ahead and jump up to the mic.
I know you're finishing up, but I just had a question. I'm actually from Hawaii, and in Hawaii, one of the things that we've been looking at is the role of indigenous knowledge in space exploration, but one thing that's a big issue right now is a telescope that's being built on Mauna Kea, and the way in which it's not sort of taking into regard indigenous knowledge. But that's not really my question. My question is more about how indigenous knowledge is being integrated into some of the educational aspects of in the high schools or other in some of the research and some of the indigenous practices and knowledge that can bring sort of insights into sort of the search for extraterrestrial life and space exploration. So I'm just curious about any sort of thoughts about that.
Yep.
I can do this from my planetary protection research with Margaret. And from an elementary standpoint, we teach about Native American people from California and across the entire nation for 4th and 5th grade. And then we also talk about colonization and explorers, and talking about how to do it from an ethical standpoint, and learning about past mistakes and how we're going to deal with them in the future. So a big part of talking about planetary protection is, what if there were life on Mars? How would we be sure to be careful about what we're doing and think about the history that we face and what we want to do for the future? So I can say from an elementary standpoint, it's something that we focus on in the curriculum, and we focus really pretty in-depth about making sure that we're thinking about Native peoples and indigenous populations and how we want to face the future with that in mind. Obviously, those are 9, 10, 11-year-olds, so it's definitely different, but we're giving that to them at an earlier age.
Did you have the badges? Yeah, go ahead.
And it's less explicit than saying, here's a past story, although there are some of the stories from cultures other than sort of the European, United States in the badges. But one of the things that I think is the most generative in the badges is that it encourages the girls to think about constellation stories as, and while this is a little bit less about space science, it's about pattern recognition in the sky and how people over time have connected with space in ways that were authentic to their own lived experience. And it asks girls to come up with their own constellation story, to connect the dots in a field of stars and come up with a story. And it kind of gives them a little bit of backstory, why someone would want to have created a story, how it might be used to tell stories through time and pass that information along. And I'm still trying to memorize. In Hawaii, there's a name for every one of the phases of the moon, and I can't wait to get those committed to memory, like not just quarter, waning, waxing, gibbous, crescent. with every single one. So getting girls to just start thinking about perspective taking, I think, is a big part of it in early childhood, like when you're not quite early childhood, but you know, K3 is what we're looking at.
At astronomy camp in July, one of the activities was that each girl had a particular culture, and they investigated astronomy or constellation myths for that culture, and then we shared them out, and to recognize that there are other constellation myths, and try to look at other cultures. Not particularly specifically at the Institute, but NASA still has education funding for within the collaborative of which the Girl Scout Stars and the NASA Ambassador Program is funded to work with indigenous people on astronomy. So they're still, and so that's with some tribes in the Southwest that they do the indigenous astronomy in parallel with Western astronomy. So it's little bits and pieces.
All right, I will, another little anecdote on that subject. Some great questions, by the way. On New Year's Eve, I want everybody to remember this. Anybody remember the New Horizons spacecraft? Are you familiar with that? So New Horizons was a spacecraft launched, I guess 10 or so years ago now, that in 2015 flew past Pluto on July 15th, I think it was, and after a 9-year voyage, got 7 minutes worth of data, and then took 7 months to download that data back to Earth. But we learned so much about Pluto. If you remember seeing in the newspaper these stunning and incredible images of Pluto, and stories about mountains of ice harder than rock, made of water, made of frozen water. So anyway, the New Horizons mission was quite extraordinary. New Horizons was then put into a state of hibernation as it continued on to the outer reaches of the solar system, into what is called the Kuiper Belt. And quite by accident, not by design, on New Year's Eve, it will fly past another a so-called Kuiper Belt object, and it will take some more scientific data, learning about some of the protoplanetary objects in space that are left over. They're remnants of the formation of our solar system over 4 billion years ago. And so it'll fly past this object. And the SETI Institute actually led an effort for NASA for this object to be named, this asteroid, which otherwise had an alphanumeric designation for a long time. And one of the, or the theme behind this naming endeavor was essentially characters or creatures from mythology from different cultures all over the world. So there were, I want to say, about, 18 or 20,000 different submittals of names from, and many of these came from indigenous peoples from different parts of the world and from different cultures all over the world. As it happens, the name that was selected was Ultima Thule, which is a Norse god, and representing some of the gods of the northernmost reaches of our own planet. And so in any case, you'll also look at planetary objects, even things like Pluto, which has a lot of features that come from Greek mythology. So I think there's greater sensitivity to storytelling and the role that has, and the science, if you will, and culture of native peoples, of indigenous peoples, and integrating that also into science and exploration. So it's a great question, interesting question. There's more work to be done. We talked about STEM. I mean, I think, and I want to give a hand to teachers everywhere, because I think, you know, the unsung heroes of our world are educators. You know, we have astronauts who are the rock stars of space, but there wouldn't be astronauts without educators and teachers, and they don't get enough credit for how important their role is. And on the one hand, we have women and minorities underrepresented in the sciences. On the other hand, we don't have enough boys either. I mean, we have to import and talk to people around Silicon Valley and the tech companies, and they have to hire from overseas because we're not producing enough scientists and engineers of male or female or underserved, you know, minority groups at all. So all of these areas need to improve. Programs, I think, such as those operated by the SETI Institute that can maybe stimulate greater interest at an earlier age, I think are compelling ways to improve that situation, you know, one small step at a time. And again, if we can make science interesting and exciting by linking it to interesting and exciting topics, I think we can make a lot of progress in that area. And I think, you know, programs like the Girl Scouts, another area that we're very interested in, you know, back to that question of why do we have these disparities, and what happens not just to girls but also to boys. What happens to the interest of little kids in things like space and dinosaurs that means they lose interest in high school? One of the issues, quite frankly, is if you look at our academic institutions and you look at elementary school teachers, most elementary school teachers have degrees in education. They do not have degrees in science. And they're not necessarily well equipped to teach science and mathematics and STEM topics. So one of the things we're also interested in doing is working with school systems in other examples of our kind of train the trainer programs. Can we do things like Airborne Astronomy Ambassadors program to bring better science education to the elementary school experience? So I think we can build on the programs we're developing now. If you have ideas, suggestions, thoughts, you know, please talk to us, talk to Pamela, reach out, because I think there's great opportunities here. I guess a couple of closing comments. When you're immersed in things, as Pamela and these amazing young people are, you perhaps forget how cool they are. So let me just tell you a little bit about something. They kept talking about Sofia. How many people are familiar with Sofia? About half. So some of you have never heard of Sofia, don't know what the heck it is. What is Sofia? Sofia is the Stratospheric Observatory for Infrared Astronomy. Okay, what does that mean? It's a great big 747 with a huge 2.5-meter telescope in the back and a great big door that opens up when this plane gets to 40,000 feet, and they do these 10-hour overnight flights all around the world to do observations in the infrared. They fly up high because they want to be above atmospheric water, which absorbs infrared radiation. So if you want to make measurements in the infrared, you want to be up high, higher than normal ground-based telescopes. So when you see this plane, when you see this massive 747 with this huge telescope in the back, the first thing that you say is, wow, that is totally cool. So, you know, they even forget how cool this stuff is. But I'll tell you, the teachers don't, and part of the whole point of the Sofia program, the Airborne Astronomy Ambassadors program, is teachers come back and they thought, man, that was one of the most exciting and amazing experiences I ever had. And they bring that excitement to the classroom. Part of our work with NASA in this program is actually monitoring the success. Did it have an impact? Did it make a difference? Are more kids getting interested in STEM? Are they following through? We check them 3 months later, 6 months, a year, 2 years, et cetera. So it is all about having impact. We care that it makes a difference, but it's an amazing program. And then the last little anecdote on planetary protection. You're going to like this one. So I was at NASA headquarters last week, and I met with the woman who has perhaps one of the coolest titles, job titles at NASA. It's the Director of Planetary Protection. And she told me a really fun story very recently that just happened to her. She was traveling back to Washington, D.C. from wherever she had been, somewhere in the country, going through security and going up to TSA and handing her license. And the fellow looked at her license and said, Lisa Pratt, any relation to Chris Pratt? And she said, Chris Pratt, the actor? He said, yeah, the actor, Chris Pratt. She said, Chris Pratt, the actor in Guardians of the Galaxy? And he said, yeah, that Chris Pratt. And she says, no, let me tell you something. I am the Guardian of the Galaxy. She goes on to say that the fellow looked at her a little bit like, okay, I've got a nut job on my hands. You know, we better call in extra reinforcements and get them down here. But then he said, what? What are you talking about? She said, I am the Guardian of the Galaxy. Well, what do you mean? I am the Planetary Protection Officer for NASA. I am worried about protecting our planet and other planets from bad things. And he said, really, that's incredible. And she gave him her NASA ID and gave him the business card, and he held that, and he looked at her and he said, holy sh. You know what's coming. So anyway, this stuff is cool, it's exciting, and people get excited about it. When I went to NASA headquarters the very first time in this position, and I went through security at NASA headquarters, I was with a colleague, and we had said to the guards, yes, we're with the SETI Institute, and I came through, and the guy said to me, so he said, you're also with the SETI Institute? And I said, yes, I am. And he said, you guys are cool, totally awesome, keep doing what you're doing. And I'm looking around thinking, I don't know, I thought I was in headquarters of cool on planet Earth, but thank you very much. So why can't we, and let's continue to do the kinds of things that Pamela and her colleagues from the Girl Scouts and all these amazing young people are doing. Keep science cool, and let's make sure we have a science literate and informed populace that's essential for democracy. So anything we can do to help that, I think, is worth doing. So with that, I do want to remind you that we have another talk next month, Saturday, September, not Saturday, September on the 13th, I believe. It's a Thursday night. It's going to be a really fun talk. Dava Newman, who's a woman, she is on the faculty of aeronautical engineering at MIT and Harvard. She was the deputy administrator at NASA during the Obama administration, and she's been featured in articles in National Geographic and elsewhere. I think she was on the cover of Nat Geo. Among other things, she is designing next generation spacesuits that are going to be used on places like Mars, and as we go back to the moon will be used there. These are form-fitting spacesuits, which mean so that astronauts can move about more freely, because they're going to have longer, much longer excursions on places like Mars and the moon if we're going to build habitats, if we're going to do exploration there, et cetera. So that's going to be a really fun talk. I think she's also putting together some other speakers to join her for this. So if you're interested, sign up, visit our website, go to SETI Talks, and sign up for that September talk. And also, by the way, as a reminder, especially information for our new guests, all of the SETI Talks, which now number over 400 hour-long lectures in everything from advanced propulsion systems to exoplanets to astrobiology to education programs, they're all on our YouTube channel, which is called SETI Talks, cleverly enough. And you could probably get your own PhD just by watching all those videos. So take a look. There's all kinds of fun subjects. And in closing, I want to make sure that our speakers get the highly coveted SETI Talks mug that is only given to official speakers at SETI Talks lectures, and they also get the cool patch. These are highly coveted. They go on eBay for hundreds of thousands of dollars from people who have, had to sell them to pay their mortgage or something. But anyway, congratulations and thank you for a wonderful evening tonight. And we'll pass these down.
Thank you.
Yeah. Okay, that's it for this evening. Thank you again for coming. We hope we'll see you next month and at future talks for the SETI Institute's lecture series. Thank you.